Okay, this video is about arithmetic sequences. All right, so definition. What is an arithmetic sequence? It's a sequence whose consecutive terms have a common difference. Basically, to get from one term to the next, you're either adding or subtracting the same amount. That's all it is, okay? So, for example, here's one problem you might have. What are the first 5 terms? Is it arithmetic? And if so, find D, okay? So the first 5 terms, this is where you okay, first 5 terms. So I just plug in a 1 for my first term. So 5 times 1 is 5 plus 3 is 8. Put in a 2. 2 times 5 is 10 plus 3 is 13. Put in a 3. 5 times 3 is 15 plus 3 is 18. 4. 5 times 4 is 20 plus 3 is 23. And 5. 5 times 5 is 28 plus 3 more. Or 5 times 5 is 25 plus 3 more is 28. Okay, so I have my first 5 terms. Now I decide, is it arithmetic? Well, from 8 to 13, you added 5. 13 to 18, I added 5. This, I added 5. This, I added 5. So I have a common difference of 5 between each term. So my answer is yes, it's arithmetic. And D, the common difference is a positive 5. Okay? So several things to do here. On example 2. Here's a recursive sequence. Remember that depends on the one before it? So the directions say find the first 5 terms. Okay? First 5 terms. Well, the first term they already told us, 0.375. Okay? And then the equation tells us you got to add 0.25 for the next term. And I get 0.625. And I add 0.25 for the next term. 0.875. Add 0.5 to the next term. 1.125. And for the last one, I'm going to add 5 again, or add 0.25 again, sorry. 1.375. So there's the first 5 terms. The common difference, what did I do to get from one term to the next? I added 0.25. Okay? Knowing that, I can then write my expression just like before. If I know what the common difference is, that is what gets multiplied by the n. Remember, the n is the number of n sequence it is. So I say 0.25 n. Well, if I put in a 1 for n and multiply by 0.25, that's great, but that's not my first term. So what I need to do is take this first term, 0.375, and subtract 0.25 to find out what I needed to add to it. So plus plus 0.125. Alright, this is my common difference times the n, and this number represents the number I needed to either add or subtract to actually get the first term in the sequence. Okay, hope that makes a little sense. Alright, the sum of a finite arithmetic sequence. Okay, so finite means it's going to end, right? But you don't know if it could have 100 terms, it could have 300 terms, you never know. So how do you handle that? Well, here's an equation, and you need to work with this well, okay? So the sum of n terms, that's however many terms you need to add up. You take that number, divide by 2, and then multiply it by the sum of the very first term of the sequence and that term later on. Like if it's the 100 terms you're adding up, this is the 100th term. So let me show you how to work this, okay? Here's the problem. Find the 150th partial sum of the sequence. All right, here's my sequence. I need to know what the 150th is. Well, I don't really want to count that out. How do I handle this? Well, the first thing I need to do is find the expression. So I begin to look, what's the common difference here? From 5 to 16, I needed to add 11. Adding 11, adding 11, adding 11. So 11 is my common difference. So I know my equation is 11n. Well, 11 times 1 gives me 11, not 5. So 11 minus what gives me 5? Well, minus 6. So there's my expression. Now I need to find the nth term. Well, n is 150. So I need to do 11 times 150 and then subtract 6. So I use my calculator. And I get 1644. That is my 150th term. Okay? Or a sub 150. Now I plug it into the formula. Well, the formula says the sum of, and we're going to the 150th term, equals 150 divided by 2 times, well, a sub 1 is the first term of the sequence, that's 5, plus a sub n. What is the 150th term? We just calculated that, 1644. All right, so I just put this in my calculator. Just remember to do what's in the parentheses first, then multiply by your fraction. And I get my solution, 123,675. That is the 150th term of that sequence. For class, I want you to try this one. Follow the same steps we just did. Find the expression, find the nth term, in this case the 27th term, and then plug it into your formula to find that partial sum. Good luck and see you in class.